Now we'll see TCP Reno. This is a newer version than TCP Tahoe. In TCP Tahoe, there are only two states, right? Slow start and congestion avoidance. Recall, whenever three duplicate acknowledgements arrives, otherwise congestion window greater than or equal to SS threshold. In both of the cases, we reached congestion avoidance state, correct? But here what we do is, for congestion window greater than or equal to SS threshold, we go to congestion avoidance. Whenever these three duplicate acknowledgements arrives, okay, we are going to count them. When you get three duplicate acknowledgements, then we do, we go to fast recovery state and do this action. We will see that actions later, but first of all we'll see high level idea. Initially we will be in slow start. Now whenever acknowledgement occurs, a proper acknowledgement, then we increment congestion window, we know that, right? So that will be the behavior of slow start. Now we'll see when we will come to fast recovery. When you are in slow start, okay, so let me mark it, this is covered, right? Now whenever three duplicate acknowledgements comes, then we will be doing this one. What is that? We reduce the threshold size, okay? SS threshold will become congestion window by 2. Okay, that means what? We are simply guessing that there is a congestion at that time, so we will be reducing this one. Did you remember? Example, there is a person who were eating 100 laddus. Suddenly one unexpected event occurred. Then what he will think, right? Recall. So his capacity 100 laddus. After eating 70 laddus, what happened? He got some problem. Then he has to reduce his limitation, capacity, right? From now onwards, he should think that no, actually my capacity is not 100. I should keep my capacity to 50, and I should tell everyone that I can eat up to 50 laddus, not 100 laddus, right? In the same way, there will be initially some threshold, like this network's congestion level. So that will be example 100 bytes for simplicity. That means this network can be operated without congestion up to 100 bytes. That means a sender can send up to 100 bytes without worrying about congestion. That is initial idea. But whenever three duplicate acknowledgement occurs, that means there is a slow light congestion. That's why you got duplicate acknowledgements. That means your packet has not been received so far, some of the packets. That's why you are getting duplicate acknowledgements, right? So in that case, we reduce our capacity. That's why whenever from now onwards, you remember, whenever some unexpected event occurs, we reduce SS threshold always by current congestion window by 2. Example, current congestion window is something 100, then we do 100 by 2. It doesn't mean that always we are reducing the SS threshold. Example, initially let's say your SS threshold is 100 bytes. After some time, let's say at this moment, let's say your congestion window is 1000 bytes because of this implementations and all. At this moment, three duplicate acknowledgement occurs. Okay, then what are we going to do? We are going to reduce SS threshold to congestion window by 2, 1000 by 2, which is 500. Is it not greater than 100? Yes, that's why in this process we are tuning SS threshold. Okay, so one day what happened? Some person is eating lot of laddus. Let's say initially he thought he can eat only at most 100 laddus, but one day when the laddus were very good, so let's say he ate some 1000 laddus, then he can change his range. Now from now onwards he can boast that I can eat more than 100. So he will be making this to something around 500 or 700. He can say from now onwards I can eat up to 700, I don't have any problem. In the same way here also, whenever three duplicate acknowledgements occurs, at that time we will be doing SS threshold equal to congestion window by 2. Whatever the congestion window we have, by 2 we are taking and we are equating it to SS threshold. After that, congestion window should be equal to SS threshold plus 3. This is the idea about moving from slow start to fast recovery. In one line I will tell you now. Whenever three duplicate acknowledgements comes, you count them, do this action. What is that? SS threshold should be congestion window by 2 and your current congestion window equal to, now we are restarting congestion window. In slow start generally we make congestion window equal to 1, correct? Whenever we begin slow start, but whenever we begin fast recovery, we will be keeping congestion window equal to SS threshold plus 3. Okay, so that means we are not starting from scratch, remember it. So this is about fast recovery. In the fast recovery, what are we doing? We will see. Okay. Before going to fast recovery, we'll complete this slow start and congestion avoidance first of all. Let's say there is no fast recovery. What are the actions we are doing with slow start and congestion avoidance? We'll see. Initially, we started slow start. So if initial SS threshold will be some value, we fix it. Designers will fix it. Congestion window will be 1. Okay. Now, whenever remember this timeout occurs, then always we can tell that there is a congestion, right? So immediately we will go to again slow start. See the edge. When you are in slow start, when there is a timeout, again you start in the slow start. But congestion window, see the idea. SS threshold will become congestion window by 2. Already I told you. Some unusual event occurs, we do like this. Congestion window by 2 equal to SS threshold equal to congestion window by 2. And we initialize congestion window equal to 1 and we start it again. Sir, after that, a good acknowledgement comes. See, if a good acknowledgement comes at any time in slow start, we increment congestion window equal to congestion window plus 1. So that exponentially we will increase our window. Don't worry. Okay. Remember one thing, when you are in slow start, we start at congestion window 1, then we make it 2, 4, 8, so on. So exponentially. Suddenly something happens like timeout, then we will be making congestion window 1 and we are again beginning with that number 1. Then again we grow exponentially. So remember, in slow start state always we are growing exponentially. Okay. Now when we will be move to congestion avoidance, you see, whenever your congestion window size greater than or equal to SS threshold, initially you kept some SS threshold and you are updating it, right? Then whenever at any time congestion window greater than or equal to SS threshold, that means what? Example, let's say your threshold of laddus is 100 at this moment. At this moment you are thinking that you can eat up to 100 laddus. Suddenly, one day in one function you are eating laddus. Okay, 1, 2, 3, 4, very fastly. First you took 1, there was no problem. You took 2, there was no problem. Then you took 4, 8, 16. Then in that way, your congestion window or otherwise the number of laddus you are eating at this moment becomes suddenly 100. Then what you do? Whenever you reach that 100, then you should be very careful, because this is the place which is your maximum capacity. After that, yes, this is only guess, right? Still eat, no problem, but don't eat exponentially. That means don't take 200 more laddus. You eat 1 laddu, then 1 laddu, in that way. After 100 laddus, one by one we eat. In the same way here also, whenever you are in slow start, congestion window greater than or equal to SS threshold, then this is the landmark for congestion. We understand that there is a congestion, we will go to congestion avoidance state. In this congestion avoidance, our behavior is like this. We simply try to increment our congestion window with very less value, so that we somehow avoid this congestion. For that, congestion window equal to congestion window plus 1 by congestion window is the incrementation. Now see here, when a new acknowledgement comes here, that means what? Still network doesn't have any problem. That's why you are getting acknowledgements in the right time. So we increment congestion window equal to congestion window plus 1 by congestion window, not 1, because we are not growing exponentially here. Okay, so that's why I can say this is additive increase. Okay, not exponential increase, additive increase. Now let me mark this one. We understand this idea. Whenever a good acknowledgement comes, we do additive increase. What are the unusual events here? We will see. When we will go back to slow start, we'll see. There is an edge to go back. Whenever timeout occurs, remember one thing. Whenever there is a timeout, that means definitely there is a congestion. Whenever there is a congestion, you should go back to a state where you have to start from the scratch. Understand? So that means whenever you are in congestion avoidance, if timeout occurs, again SS threshold, your traffic idea should be reduced. That means you thought traffic maximum traffic allowed is something, right? SS threshold, that should be congestion window by 2. These are all our guess. Okay, like laddus, remember it. So SS threshold is a parameter. Initially we thought it is 100, slowly it will be reduced 50, 25. We are tuning it such a way that is finally going to predict exact congestion. Okay, so this SS threshold equal to congestion window by 2. What is the usage of SS threshold? Using the SS threshold, we are moving from slow start to congestion avoidance. Let me ask one question. How your TCP will understand that we should go to congestion avoidance state based on this SS threshold? What is SS threshold? Initially very large number, but after getting lot of traffic problems, you understand when you what is traffic problem. Whenever there is a timeout, that means there is a traffic, then we reduce our guess. Initially we thought 1000 bytes is the maximum congestion window size we can have. We reduce it in that way. Always SS threshold will be reduced whenever congestion is detected. That's why here whenever congestion is detected, SS threshold equal to congestion window by 2 and congestion window equal to 1, and go to slow start, and you know the remaining story. In slow start what we do, if a good acknowledgement comes, increment congestion window. If again congestion window reaches greater than or equal to SS threshold, then we come to congestion avoidance. I'm not discussing this one at this moment, okay? We will see this activity also. So finally you understand how to move from slow start to congestion avoidance to slow start. And anything else, when you are in congestion avoidance, a good acknowledgement comes, then we increase the window size of congestion window additively plus very slowly, okay, not multiplicatively or exponentially. But in slow start we do exponentially. We know that, right? Though it is +1, but that is a exponential incrementation, right? Now let me introduce fast recovery. So what is fast recovery? It is a state in between slow start and it is congestion avoidance. How? In fast recovery, we start with, you see, always whenever you come to fast recovery from slow start, generally when we will come, we'll see first. When you are in slow start, if 3 duplicate acknowledgement comes, generally in Tahoe, if 3 duplicate acknowledgements comes, then we will go to congestion avoidance. But here we'll come to fast recovery. Okay, what is the idea about fast recovery is, here just fast recovery means we are assuming that there is a light traffic. Okay, whenever we go to congestion avoidance, we assume that there is a heavy traffic. That is what the idea. Now when you are in fast recovery, already 3 duplicate acknowledgements arrived, then we initialize our congestion window to congestion SS threshold plus 3. What is SS threshold? Congestion window by 2. Okay, now remember one thing, whatever the SS threshold you have, whatever the congestion window you have, when you move from slow start to fast recovery, the current SS threshold will become congestion window by 2 and the congestion window equal to SS threshold plus 3. Example, initially your SS threshold is 100 bytes. Then when 3 duplicate acknowledgements comes, then SS threshold will become congestion window by 2. What is congestion window initially at this moment? Let's assume that, let's say your congestion window is 6 bytes at this moment when we are moving from here to here. So then SS threshold will become 6 bytes by 2, 3, and congestion window equal to SS threshold plus 3. 3 plus 3, 6. In that way we update. Don't worry about them. Okay. So just remember the instructions. That is enough. Now you are in fast recovery. In fast recovery what we do? Sometimes we go back again. When will we go back? Timeout occurs. The beauty of this TCP Reno and TCP Tahoe, wherever you are, whether you are in fast recovery or congestion avoidance or slow start, when timeout occurs, same story. What is that? Keep quiet, make congestion window equal to 1 and start from the scratch and go to slow start state. See, when you are in fast recovery, timeout occurs, then SS threshold should be congestion window by 2. It is quite normal everywhere. Congestion window equal to 1 and start from scratch again. Okay, done. So from fast recovery we can move to congestion avoidance. When, see, when new acknowledgement comes, immediately we'll go to congestion avoidance. At that time congestion window should be equal to SS threshold. So all these things are fixed by experience. Don't worry about them, because whenever some algorithm is, this kind of protocol is designed, they will take care of lot of things. They will do lot of experimentations and they fix these values. That's why as a GATE student you just remember them. That is enough. Okay, now remember one thing, when we are in fast recovery, a new acknowledgement comes, what we do? We go to congestion avoidance state, but initialization is like this. Congestion window should be updated to SS threshold, anything, not more than that. Okay, so now finally we understood how to go from fast recovery to congestion avoidance, how to go from fast recovery to slow start. For that, what should be the necessary input? Now, one more input. Sir, when we are in fast recovery, actually why I came to fast recovery from slow start? Because of three duplicate acknowledgements. Again that continues. One more duplicate acknowledgement comes. Another duplicate ACK comes. Then we are going to do congestion window equal to congestion window plus 1 like slow start. That's why fast recovery is like slow start with respect to the incrementation of congestion window. So that's why here also your congestion window is growing exponentially, not additively. Remember it. So that is one thing you should remember. Okay. Now we understood what is fast recovery, and we have to cover only one case. From congestion avoidance also we will come back to this fast recovery when we will see. When you are in congestion avoidance, this is the input you see. We will come back to fast recovery when three duplicate acknowledgements comes. That means finally fast recovery is all about having three duplicate acknowledgements at any moment. Okay. When you are in congestion avoidance, count the duplicate acknowledgements whenever they are three. See, SS threshold equal to congestion window by 2 as usual, but congestion window equal to SS threshold plus 3. Here also same thing, correct? So that means we are incrementing congestion window by 3, SS threshold plus 3. For each duplicate acknowledgement, one incrementation. For 3 duplicate acknowledgements, 3 incrementations to SS threshold. What is SS threshold? Congestion window by 2. Okay, then we'll come here. This is the final story. What you do is just, remember this diagram, that is more than sufficient. So far there is no question, nothing. So try to understand 80% of it, that's it. Okay, try to go through it, remember whatever you can, that's enough, because question may come, may not come, and you may remember all the things, you may not. That's why, so whenever this kind of things when you are preparing, then don't put all your efforts, because whatever the effort you put, because you have lot of information, right, you can't remember all the information, but not a matter. Okay, what is important is, did you understand the idea, did you understand the major instructions? That is enough. Every instruction is not really required. Okay, now let me summarize it. When you are in slow start, when congestion window greater than or equal to SS threshold, go to congestion avoidance. When you are in slow start, if three duplicate acknowledgements comes, then come to fast recovery. When you are in congestion avoidance, timeout occurs, go back to slow start. When you are in congestion avoidance, if you get a right acknowledgement, then be here. When you are in congestion avoidance, if again three duplicate acknowledgement comes, come to fast recovery. By that time, so far, if only one duplicate acknowledgement comes, stay there, don't do anything in that way, simply count it. So count all the duplicate acknowledgements. Whenever you accumulate 3, then come to fast recovery. Now when you are in fast recovery, if again a duplicate acknowledgement comes, stay there. When timeout occurs, go to slow start. When you are in here, if again new acknowledgement comes, go to congestion avoidance. That's it. If you remember that, so you can understand, solve anything, not a problem. Okay, this is about TCP Reno. TCP Reno is also called a class of algorithms. That means this TCP Reno belongs to class of algorithms called AIMD algorithms. AIMD, additive increase, multiplicative decrease. Okay, so why this is called additive increase, multiple decrease, we will see. Whenever see this congestion avoidance state, whenever you are in, forget about this slow start. Okay, assume that, let's say, most of the times we are spending here and here. That is what the observation, what people realized is, slow start is very small phase, because exponentially you are growing, right? When you are exponentially growing your congestion window, quickly it will cross this SS threshold and you will come here. That means slow start is temporary to quickly improve you. Understand? So these two are long term, I can say. So in congestion avoidance, we are increasing the window additively, correct? Plus 1 by CW window. That means for one round trip time, only one unit we increment, correct? That's why it is additive increase, slow increase. Second one, multiplicative decrease. Okay, so MD means multiplicative decrease. Additive increase, multiplicative decrease. Sir, where is multiplicative decrease? in this state, you see, fast recovery. So when we go from congestion avoidance state to fast recovery, when three duplicate acknowledgements comes, then we are doing SS threshold equal to congestion window by 2, congestion window equal to SS threshold plus 3. So here, what is SS threshold before this step? Congestion window by 2. Let me write it. Congestion window by 2. That means effectively your congestion window equal to congestion window by 2 plus 3. Let's ignore 3. Then approximately it is congestion window by 2, correct? That means when you are in congestion avoidance, 3 duplicate acknowledgements comes, then we are reducing the congestion window to congestion window by 2. That means we are decreasing the congestion window multiplicatively, right? Because we are dividing it by 2. When it is 100, we are making it 50. If it is 50, then we are making it 25. That's why we say that there is a multiplicative decrease for your congestion window. That's why this TCP-Renault algorithm is also known as AIMD algorithm, additive increase, multiplicative decrease. Okay.